700-degree red soup clings to grooves, flows out. Through workers' skilled pinpoint pressurization, it becomes giant rice sticks almost 10 meters long. This forms precision aluminum-magnesium alloy plates. Aluminum-magnesium alloy is vital to electronics, from cars to aerospace, seen as godlike. Today, we arrive at the factory known as Shaosanlin. First, we will see a wide variety of exhibits, and this oddly shaped aluminum plate is the material to be crafted in this round. Before we begin, let's first understand what aluminum-magnesium alloy is. Aluminum-magnesium alloy is based on aluminum, with the addition of 1% to 12% magnesium. This increases the strength of the aluminum alloy. After smelting, the aluminum ingot becomes a red liquid at 700 degrees C. However, it cannot be directly used for casting. It flows into a storage tank, where silicon, iron, copper, and magnesium are added to adjust composition. Once the aluminum ratio is set, equipment starts high-frequency slag removal. And this oxidizes the impurities, allowing them to float on the surface. Now we come to the second quality inspection, which is the most important step before casting. The factory will pre-solidify a block of aluminum ingot, then cut off the surface through a process, and use a robotic arm to place it on the inspection table. Only in this way can the element ratio in the aluminum melt be revealed, allowing it to proceed to the next step of casting. First, 4 sets of iron frames are placed on the aluminum rod casting machine. Then the equipment is started, and we will see this massive machine slowly tilt to the other side. Rainwater will also continuously flow outward following the angle of the equipment, making this process the most tense moment. During this time, not only are the hands constantly busy, but the body is also alternately standing and bending, requiring the presence of 2 people throughout. This continuous observation may seem calm on the surface, but underneath, it is turbulent, with each casting consuming tons of water. This allows the aluminum rod to cool rapidly and solidify. This process is essentially pulling the billet. As long as the depth below is sufficient, whether it's 10 meters or 100 meters, it can be pulled out. Although the length is not an issue, the workshop is not that tall. So most of the time, a length of about 10 meters is used, which can then be pushed upwards. Once the aluminum rod reaches the specified size, the ring can be separated. They are fixed above the aluminum rod, then lifted all at once by a horizontal hoist. Its enormous size becomes apparent at this moment. Without much to say, one rod must weigh at least 200 pounds. After all, its diameter is thicker than a thigh, and it's a solid structure. It is then slowly lowered, and the other side is thoughtfully equipped with a solid barrier to prevent it from slipping out accidentally during the process. At this point, the aluminum rod is formed, and begins the second process of making aluminum plates. First, the aluminum rod is pushed into the machine, and the saw blade on one side immediately starts after sensing it. Then it is cut to the specified size, then transmitted forward, and pushed from behind into an electric furnace for heating. This process does not take too long. Generally, it will be heated within 2 minutes. After heating, the aluminum rod is transported via the conveyor belt below to the front, and then further extrusion begins. The tonnage of the aluminum extrusion machine is quite heavy, and you can see visible changes on the screen with almost no effort. The exit quickly takes on the appearance of an aluminum plate. Then the device on the left clamps a section and pulls it forward, extruding as it pulls, making the process appear very efficient. It only takes a moment for the length to reach the specified requirement. Then a saw blade cuts the connection point, and it is immediately transported forward in a lateral manner. However, the cutting position varies in length each time. Therefore, one end must be fixed under the pressure of the furniture, pulling forward with full force, so that the length on both sides always remains at the same point. Once 3 aluminum plates are aligned, the conveyor belt at the bottom can start simultaneously. Dragging it to the cutting process, you can actually see from here why it is necessary to align both sides, because only by cutting neatly can material be saved. Otherwise, you'll end up with a pile of scraps, which are then lifted by the equipment and stacked in the same position. Next, it enters the most important step of the extrusion process, heat treatment. As we all know, aluminum alloy is made by forceful pulling and stretching, resulting in very high rigidity within the metal. Only through proper tempering can this rigidity within the aluminum plates be eliminated, making it more durable. Another important point is that the tempered aluminum plate appears brighter. Note that this brightness is not the same as the initial shine. Rather, it emits a subtle reflection on the surface, which enhances its aesthetic appeal when used for decorative purposes. Moreover, compared to regular aluminum alloy, the hardness of magnesium aluminum alloy is also higher. Now let's take a look at the details. Do you know where this type of aluminum plate is used? It is used in trucks as body panels. Its strength is certainly not as high as alloy steel, but the reason for using magnesium aluminum alloy might be for aesthetic purposes.